Okay, welcome. This is a section on 6.1, Hamilton circuits and paths. The good thing is that this is very similar to the last section we talked about with Euler. If you can do me a favor and write this down at the top of your page. So Hamilton graphs and Euler graphs pretty much look exactly the same. You're going to have the same edges, the same vertices, a lot of the same language. The difference, though, is that there's a slight difference between what a Hamilton graph does and what an Euler graph does. Let's start by first writing down what a Hamilton circuit is. If you can write for me, Hamilton circuit. So a Hamilton circuit is a circuit, remember, a circuit that starts and ends in the exact same place. So it is a circuit, except this time it's going to, I'm going to write here that it visits, meaning it goes to, each vertex once. That's the big difference. I'm going to put vertex in all caps. It visits each vertex once. Of course, when you close your circuit, you're going to have to go, you leave your starting vertex, then you come back to your starting vertex. So really, I'm going to make a special note here, except at the end. So that's the Hamilton circuit. A Hamilton path. Same thing. It's a path that visits each vertex once. Just like the last one, except it's a path instead of a circuit. So let's go over what those are going to look like and how those are solved. But before we do that, let's compare to see how that is different from an Euler circuit and path. So let's recap real quick what an Euler is. So I'm going to write over here Euler circuits and paths. And we're going to compare that to a Hamilton circuit and path. So I'll put that over here on the right-hand side versus a Hamilton circuit and path. All right, so with an Euler circuit, remember, in order to be an Euler circuit, what does it have to have? Hopefully you just said in your head that it has to have no odd vertices. All your vertices are even. What does a Hamilton path, or excuse me, an Euler path have to have? Hopefully you just said in your head it has to have two odd vertices. Whenever you start at one and you finish at the other. A little recap from last section. Hamilton circuits and paths. You know how there's a shortcut to find a circuit? You just count your number of degrees to figure out if it's a circuit, a path, or if it's in either. For Hamilton circuits and paths, I got bad news for you. There is no shortcut. No shortcut. There's no way to figure out if there's a Hamilton circuit or path unless you actually just do the problem. But an easy way to remember the difference is that Euler circuit goes through all edges. In fact, I'm going to underline the E in Euler and the E in edges. Euler goes through all edges. Euler starts with E, edges starts with E. Hamilton, on the other hand, goes through all vertices, not down all the edges. There are lots of professions that use Hamilton circuits. You actually do a Hamilton circuit every time you leave your house and decide to stop at a couple different stores or places to visit. We'll go over how to use Hamilton circuits in a little bit, but for today, let's figure out what they look like and how we can use them. Number one, we're going to do 4 examples. Here's our first one. We're going to basically set these up exactly the same way. We're going to put point A here, point B here, point C I'm going to put down here, point D I'll put over here. And I'm going to make a box connecting all of those, kind of like this. And then inside, I'm going to cross, make an X on the inside. And the point where they cross, I'm going to call point E. So I'm going to ask you the same 4 questions for each of these 4 examples. I'm going to ask you, is there an Euler circuit? I'll put EC for Euler circuit. Is there an Euler path? Is there a Hamilton circuit? Is there a Hamilton path? All right, so for the Eulers, since we did those in the last section, we're not going to go through and figure out what they are. I just wanted somebody to figure out if there is one or not. So let's practice with Euler. Remember, for an Euler circuit, you have to have all even vertices. Let's check your degree. The degree of A is 1, 2, 3. So that right there means there's no Euler circuit. I'm going to write none next to there. For an Euler path, I have to have exactly 2 odd vertices. A is odd, B is 1, 2, 3, B is odd. C is odd because it has a degree of 1, 2, 3. So right there, I've got a degree of 3. I've got 3 odd vertices. It is not going to be an Euler path. Notice D is also have a degree of 3, so D is also odd. So it has no Euler circuit. It has no Euler path. However, it does have a Hamilton circuit because a Hamilton circuit starts in one place and finishes in another. I'll start at vertex A, although really, unless it says, you can start anywhere that you want. So starting at A, I want to go to all the vertices. I don't have to go through all the edges. So I'm going to go from A to E, E to B, A, E to B, B to C, C across to D. I've been through all my vertices, so now you go back and you close your circuit by going back to where you started from, which is vertex A. Again, that's just one possibility. There are lots of choices you could do. You could do A, B, C, D, E, A. You could do A, D, E, C, B, A. There's lots of different ways you can do it. That's just one example of a Hamilton circuit. We're only going to write down one for each of these. A Hamilton path, if it doesn't say anything specific, just rewrite what you wrote for a Hamilton circuit and just take off the last letter. We'll try to think of something different because we're going to be creative. Let's still start at A, and this time let's go to D after that. So A to D. Let's go E to C to B. I started at A, I finished at B, I went through all my vertices, I'm done. That's a Hamilton path. Let's do example 2. Again, I'm going to draw pretty much the exact same shape. I'm going to draw A up here, B over here, C at the bottom, and D over here. I'm going to put E in the middle. Except this time, I'm not going to make a box. I'm going to connect A to B, D to C, and then I'm going to draw my X. So we're going to figure out if there's an Euler path, Euler circuit, Hamilton path, and a Hamilton circuit. Let's start with Euler. Is there an Euler circuit? Count your degrees of your vertices. This is a degree of 2, 1, 2. So does B, so does D, so does C. All of these are even. E is also even because it has a degree of 4. They're all even. There is an Euler circuit. Again, we're not going to figure out what it is because we did that in the last section. We just know that there is one. If there's an Euler circuit, there's not an Euler path. You can't have both. Now let's do Hamilton circuit and Hamilton path. So Hamilton circuit, we'll start at A. If I go A to B to E, I can do then C, D, but I've got no way to get from D back to A because I have to go through vertex E, and I can't go through vertex E because I've already been to vertex E, and a Hamilton circuit cannot repeat any vertex because you go through each vertex once and only once. If I were to start at E, and I were to go up and do A, E, or E, A, B, I can't go B down to the very bottom because I have to cross through E again. In other words, there is no Hamilton circuit. However, there is a Hamilton path, but you cannot get a Hamilton path if you start in the middle. You have to start at the top or start at the bottom. It doesn't matter which one you start at. Since we've been starting A, we'll keep that the same. So let's do A, B, E, C, D. Hamilton path, starting at one vertex, finishing at another, not repeating any vertices. Number 3. All right, so we're going to put our same vertices, A over here, B over here, C and D. We're going to keep E in the middle. We're going to draw basically the same shape we drew in number 1 with our X in the middle. Except this time I'm going to add like a roof to my house and call that vertex F up there. And a roof at the bottom of my house, call that vertex G at the bottom. I'm going to ask you the same 4 questions. Euler circuit, Euler path, and then we'll do both the Hamilton circuit and the Hamilton path. So Euler circuit, they have to all be even. Are all the vertices even? Go ahead and pause the video. The answer is yes, they're all even. So there is a Euler circuit. If there is an Euler circuit, it means there's not an Euler path. Now let's do Hamilton circuit. So let's start, I don't know, at vertex A. Let's go A to F to B. Let's go B to E to C. Let's go C to G to D. And let's go D, close my circuit, back to A. I started at one vertex, I finished at another, and I went through all the vertices. That is a Hamilton circuit. Hamilton path, again, if you wanted to cheat, you could just simply take off the last letter. There's a Hamilton path. I started at A, finished at D. Let's do a different one. Let's start at a different letter. Let's get real crazy. Let's start with vertex E this time. So we're going to start in the middle. What if I did E, C, G? So E, C, G. Then I go up to D. Then I go up to A. Then I go all the way up to F and down to B. I started at E, I finished at B, I went through all the vertices. That's a Hamilton path. Number 4, last one. So we're going to put our vertices very similar to the way we've done them before, A, B, C, and D. I'm going to draw a box just like I drew with number 1. I'm going to put point E in the middle. Except this time I'm going to have a point going straight up and call it F from A, a point straight up from B and calling it G, a point straight down from C, calling it H, and straight down from D and calling it I. Again, same 4 questions. Is there an Euler circuit? Is there an Euler path? Is there a Hamilton circuit? Is there a Hamilton path? Hopefully by this point you can tell right away if there are or not. So Euler circuits have to all be even. Are all the vertices even? They're not. F is odd, G is odd. So it is not an Euler circuit. Is it an Euler path? Again, no, it is not, because not only is F and G odd, but so is I and H. You have more than 2 odd vertices. So you have no Euler path, no Euler circuit. Pause the video and see if you can find a Hamilton circuit. Yeah, I couldn't either. There's no Hamilton circuits. Pause the video, see if you can find a Hamilton path. Yep, I couldn't either. There's no Hamilton paths. And that is 6.1 Hamilton circuits and paths.